Okay, I want to talk a little bit about the alternatives to RAID. The primary alternative to RAID is a better file system that, instead of expecting the disk controller to manage the disks and understand how to handle these complex operations, this is actually moved up into a processor. And this is actually going to lead us into how file systems are managed across networks a little bit later in the class, which we're going to spend a little bit of time on. But BTRFS, okay, BTRFS is a better file system. I put a link in the notes. I highly recommend going and giving a quick read to the Wikipedia page, although it's a little bit out of date. It has a good overview, and I'm actually going to look at some of the features out of it. But as far as I'm concerned, the big features are that it has snapshots. Snapshots is a way to back up data by being able to say, at this moment in time, give me all the data on an entire disk and make it so that I can read that, even though future things are making changes to it. So it can take a quick shot of what's there. There are checksums, so that every time it reads a block, it can look at the checksum and determine if that block is corrupted. And if you combine that with system level RAID 1.0 so that you have duplication of data or multiple stripes of the same data, then it can simply go to one of the other stripes of that data and pull out that block and give you a correct block. It has built-in capabilities to monitor that sort of thing and reconstruct blocks based on invalid data. And pooling. One of the big advantages of BTRFS is that it allows you to take a set of disks and combine that set of disks in together to make a single volume. Also, the amount of size that it can handle is truly huge. It's 16 times 2 to the 60th blocks of data. The blocks are fixed size. They're not huge blocks. I believe it's 4K. But that is a lot of data. Way, way more than pretty much any other file system out there, including the one that Sun developed some years ago called ZFS. So it's got a lot of features. Okay, if you go to the Wikipedia page and look at it, it goes down and it lists some of the features that are currently there. It's now a supported file system in Linux. The advantage of it the disadvantage is that it's in Linux as opposed to a file system that is available in Windows. So if you want to use something like this and have a file share, the way to do it is you use some network tool like Samba so that you can share Linux drives as a window file system. And if you're familiar with on campus, the H drive on systems that you log into is a shared file system. It's not really on the computer that you're on. So the sharing of files across systems across a network is really common and works quite well for an awful lot of applications. On a Linux system, you can use it these days for your root file system, so that you can actually build a system that boots directly off of this. Notice that it does use RAID, but it uses RAID at the level of the file system, not at the level of the hard disk controllers themselves. So it has a bunch of nice features, and it makes for a file system that's high reliability, especially if it's implemented across systems. This is the file system that's being used by Backblaze underneath the covers, but it's actually doing another layer on top of this so that entire systems are done with RAID 1.0 so that there's duplication of data on top of a BTRFS file system. So that's one kind of an alternative. Another alternative that is radically different is one that was developed by Google, and that is the F1 database. Google saw a need for having a database that could extract data, and instead of building a database, they took MySQL and they renamed it F1 and they ported it to run on top of this other file store called Bigtable. Bigtable is the world's first world-scale database. It runs in data centers. It uses some amazing synchronization based on a 1982 paper by this guy Leslie Lamport, a Turing Award winner. And The way that it synchronizes is using clocks to get the synchronization time to be fast. They actually put atomic clocks in their data centers that this database uses for its synchronization. There's another version of this that does not have the high-speed synchronization that's open source called CockroachDB. I hate the name, but it's a great database, a great application. So these other databases that use distributed data have the advantage of being able to have ultra-high reliability and consistency with fault tolerance, because they're always checking that the data that they're reading is correct, that there are checksums, that they are synchronizing across locations, and they do it at a massive scale. Probably some of the people in this class have used things like Google Docs and Gmail, and they're sitting on top of the F1 database, as well as hundreds and hundreds of other companies outside of Google that use the Google Compute Cloud and the Google F1 database for their applications. So there's lots and lots of people using this, and it is truly a world-scale database running on millions of computers simultaneously. So that's kind of my tour into RAID and what you do with it, and what its disadvantages and advantages are. We're going to come back to looking at how you store things across networks. Sun's moniker for their company before they were bought by Oracle was "the network is the computer," and we're going to look at how you store data not locally, where it's all done across a network. But we're going to talk about that in the context of networks, and the reason why we're doing RAID and networks is because these are the biggest sources of input-output in computer architecture. So we'll come back to that. We'll take a brief time looking at things like Samba as an application and how the distributed file systems work, and some other distributed file systems like NFS, and also one of the most modern ones, which is a thing called interplanetary file system, IPFS. And all of these are file systems that are built to run across networks, as opposed to attached to an individual computer. The F1 database from Google is kind of in between, since it both runs locally and it also runs distributed. All right, until next time.